July 15, 1944. Oberfeldwebel Hans Kruger crouched behind his Flak 88 anti-aircraft gun position outside Caen, France, watching American Sherman tanks approaching through the wheat fields. His crew had trained for 6 months on this weapon. The 88mm Flak 36 was a legend. It could destroy any Allied tank at 2,000 meters, penetrate 180 millimeters of armor at 1,000 meters, engage aircraft at 10,000 meters altitude. It was the most feared gun in the German arsenal, the most versatile weapon of World War II. And it was also the gun that was losing Germany the war. Not because it couldn't kill, because Germany couldn't build enough of them fast enough. Each 88mm flak gun required 12 weeks of manufacturing time, 530 precision-machined parts, 120 skilled workers, 17 different factories contributing components. The Americans had a gun that was almost as good, the 90mm M1. It required 2 weeks to build, 180 parts, 40 workers, 3 factories. By July 1944, the production mathematics had become a death sentence. Germany had built approximately 21,000 Flak 88 guns total since 1933. 11 years of production. America had built 20,000 90mm M1 anti-aircraft guns since 1940, 4 years. The weapon that won wasn't the most perfect. It was the one you could build fast enough to matter. This is the story of how German engineering excellence destroyed German strategic capability, how the pursuit of perfection became the enemy of production, and how America won the gun war, not by building better weapons, but by building adequate weapons overwhelmingly faster. The Flak 88 story begins in 1928 when the Treaty of Versailles theoretically prohibited Germany from developing heavy artillery. Krupp engineers, working secretly, began designing a new anti-aircraft gun under the designation Gerät 88, Device 88. The original purpose was purely defensive: shoot down enemy bombers. The first prototype fired in 1928. The production model, designated Flak 18, entered service in 1933. Caliber 88mm. Barrel length 56 calibers. Muzzle velocity 820 meters per second. Maximum range 14,800 meters vertical. Effective ceiling 8,000 meters. Rate of fire 15 to 20 rounds per minute with trained crew. The gun weighed 5 tons in firing position. It could be towed by a half-track at speeds up to 40 kilometers per hour on roads. The mount allowed 360-degree traverse and -3 to +85-degree elevation. This meant the gun could engage targets from directly overhead to nearly flat trajectory ground targets. The versatility was accidental genius. The Spanish Civil War proved the concept. German Condor Legion deployed Flak 88 guns to Spain in 1936, supporting Franco's nationalist forces. Lieutenant Colonel Wolfram von Richthofen, commanding the Condor Legion's anti-aircraft units, discovered the 88 could destroy Republican T-26 tanks with devastating effectiveness. The flat trajectory high-velocity shell designed for aircraft could penetrate 30 millimeters of tank armor at 1,000 meters. Soviet-supplied tanks had maximum 30 millimeters. Every shot was a kill. Von Richthofen sent urgent reports to Berlin. This anti-aircraft gun is the best anti-tank weapon we have. The German army initially dismissed the idea. Anti-aircraft guns weighed 5 tons. Tank destroyers needed mobility. But France proved von Richthofen correct. May 1940. German forces invading France encountered British Matilda infantry tanks and French Char B-1 heavy tanks with armor up to 75 millimeters thick. German standard 37mm PaK anti-tank guns were useless. Shells bounced off harmlessly. Panzer commanders watched in horror as French tanks rolled through their defensive lines untouched. Then the Luftwaffe's 88mm flak batteries were deployed in ground roll. The high-velocity shells tore through French armor like paper. At Arras on May 21st, Rommel personally directed 88mm guns against British tank attack. 50 British Matildas destroyed. Rommel became an instant advocate. He demanded 88mm guns be permanently assigned to panzer divisions for anti-tank defense. The legend was born. But the legend created a strategic nightmare. The 88mm Flak gun was never designed for mass production. It was an artisan weapon, a craftsman's masterpiece. Krupp's design philosophy emphasized perfection over quantity. Every part was precision machined to tolerances of 0.01 millimeters. The breech mechanism alone required 83 separate machined components assembled by skilled workers using hand tools and careful fitting. The hydraulic recoil system needed custom manufactured cylinders and seals. The fire control system incorporated optical rangefinders and mechanical computers for calculating elevation and deflection. The electrical traverse motors were custom-built units. Even the ammunition was complex. The 88mm shell had 6 different variants: high explosive for aircraft, armor-piercing for tanks, high explosive anti-tank shaped charge, armor-piercing composite rigid for super heavy armor. Each required different fuses, different propellant loads, different quality control procedures. Manufacturing timeline for one complete Flak 88 gun broke down as follows. Week 1 through 3, barrel forging and rifling at Krupp, Essen. The barrel blank started as 300 kilogram steel ingot, heated to 1,200 degrees Celsius, forged under hydraulic press, rough machined, rifled with 8 grooves, stress relieved, chrome lined. Final machined to exact tolerances. 3 weeks minimum. Week 4 through 6, breech mechanism assembly at Rheinmetall, Düsseldorf. 83 precision parts, each machined individually. Hand-fitted, tested for timing and extraction reliability. 3 weeks. Week 7 through 9, carriage and mount fabrication at various subcontractors. Cruciform platform, outrigger legs, hydraulic jacks, traverse mechanism, elevation gears, assembly at main Krupp facility. 3 weeks. Week 10, fire control system integration, optical sights from Zeiss Jena, mechanical computer from Rheinmetall, electrical systems, testing. Week 11, complete gun assembly and function testing, live fireproof, final inspection. Week 12, cosmetic finishing and delivery, total time 12 weeks per gun. Total labor, 120 skilled workers contributing approximately 14,400 man-hours. Cost per gun, 33,000 Reichsmarks, equivalent to purchasing 15 Volkswagen Kübelwagen military vehicles. By 1944, this production system was collapsing. Allied strategic bombing systematically destroyed the supply chain. February 1944. Schweinfurt ball bearing plants bombed. 88mm traverse mechanisms required precision ball bearings from Schweinfurt. Production halted 6 weeks. April 1944. Essen Krupp works bombed. Barrel production reduced 77%. June 1944. Düsseldorf Rheinmetall facility bombed. Breech mechanism production stopped completely 4 weeks. The distributed production system that had seemed smart in peacetime became catastrophic vulnerability in war. One disrupted subcontractor stopped the entire assembly line. Meanwhile, America approached the problem completely differently. In 1940, when war seemed inevitable, the United States Army Ordnance Department examined anti-aircraft requirements and concluded they needed a heavy gun capable of engaging high-altitude bombers. They looked at the German 88mm reports from Spain and France. They didn't try to copy it. They tried to simplify it. The requirement specification for what became the 90mm M1 gun emphasized manufacturability over perfection, designed for assembly line production, minimize custom parts, use commercial off-the-shelf components wherever possible, accept slightly lower performance if it meant massively faster production. The contract went to multiple manufacturers simultaneously. General Electric designed the fire control system. Watertown Arsenal designed the mount and carriage. York Safe and Lock Company produced breech mechanisms. Pontiac Motor Division produced electrical systems. This wasn't a craftsman approach. This was Detroit automotive thinking applied to artillery. The 90mm M1 gun specifications deliberately simplified versus the German 88. Caliber 90mm, slightly larger but using simpler ammunition with fewer variants. Barrel length 50 calibers versus 56, slightly shorter but easier to manufacture. Muzzle velocity 823 meters per second, effectively identical to German gun. Maximum range 12,000 meters vertical, 2,000 meters less than 88, but still adequate for bomber interception. Rate of fire 25 rounds per minute. Higher than German gun due to simplified breech design, weight 4 tons versus 5 tons. Lighter meant easier to move and deploy. Most importantly, part count 180 versus 530. Assembly time 2 weeks versus 12 weeks. Worker count 40 versus 120. These numbers represent completely different manufacturing philosophies. The American gun wasn't better. It was adequate. And adequate built fast beats, perfect built slow. The production system reflected automotive assembly line principles. Watertown Arsenal in Massachusetts became the central assembly point, but components came from commercial manufacturers across America. Pontiac Motor Division in Michigan built traverse motors using modified truck starter motors. No custom electrical systems. Commercial heavy-duty truck components. York Safe and Lock in Pennsylvania built breech mechanisms using modified commercial safe lock components. The concept, bank vault mechanisms are already precision engineered for reliability. Adapt them rather than design from scratch. General Electric in Schenectady, New York built fire control computers using commercial electrical relay systems. No custom mechanical computers. Use electrical relays mass-produced for telephone switching systems. The barrel production used simplified forging. Instead of 3-week custom forging process, American manufacturers used modified naval gun barrel techniques. Automated hydraulic forging, machine rifling with multi-tool cutters, chrome lining applied by industrial electroplating. 1 week from ingot to finished barrel. Assembly line production began January 1941 at Watertown Arsenal. Initial rate, 12 guns per month. April 1941, 40 guns per month. December 1941, after Pearl Harbor, 200 guns per month. Peak production June 1943, 680 guns per month. Total production 1940 through 1945, 20,000 90mm M1 anti-aircraft guns. Germany in same period, 1940 through 45, 7,500 Flak 88 guns. America built 2.6 times more guns in 5 years than Germany built in 11 years. The production rate differential, American factories produced 40 guns for every 12 weeks, while German factories produced 1 gun every 12 weeks. 40-to-1 production advantage. The strategic consequences emerged in 1944. Normandy invasion June 6th required massive anti-aircraft protection for invasion fleet and beachhead. American forces deployed 1,290mm guns protecting the beaches. German forces in Normandy had approximately 300 Flak 88 guns protecting all of France. 4-to-1 numerical advantage meant Allied aircraft faced quadruple the defensive fire suppression, while German positions were overwhelmed. The air superiority that made D-Day possible came partially from having enough guns to protect everything simultaneously. Battle of the Bulge. December 1944 showed the artillery mathematics crushing Germany. American forces defending Bastogne had 98 90mm anti-aircraft guns repositioned for ground defense against German armor. The crews had trained for aircraft engagement, but the guns worked identically against tanks. German panzer columns attacking Bastogne faced wall of 90mm fire from positions they couldn't suppress because there were too many guns. German forces had 42 Flak 88 guns supporting entire Ardennes offensive, outnumbered 2-to-1. When weather cleared December 23rd and Allied aircraft appeared, American 90mm guns provided air defense while simultaneously engaging ground targets. German 88mm crews had to choose: shoot at aircraft or shoot at tanks. Cannot do both simultaneously with insufficient guns. The deeper strategic failure was Germany's inability to adapt production methods. Albert Speer, appointed armaments minister February 1942, recognized the problem immediately. He visited Krupp factories and watched skilled craftsmen hand-fitting 88mm breech components. Speer demanded simplified production. Krupp engineers refused. They argued precision was mandatory for reliability. Speer showed them American 90mm captured examples. Similar performance: 1/3 the parts, 1/6 the production time. Krupp engineers dismissed American gun as crude. Inferior materials, sloppy tolerances. Speer asked the critical question: does it work? Yes. Does it kill tanks and shoot down aircraft? Yes. Then crude adequate beats perfect inadequate. But Krupp couldn't adapt. The engineering culture, the skilled workforce, the distributed subcontractor system, the entire German manufacturing philosophy was built around precision craftsmanship. You cannot convert craftsmen into assembly line workers overnight. The attempt failed. By 1945, the production crisis was absolute. Germany produced 412 Flak 88 guns January through April 1945. America produced 2,790mm guns same period. 6-to-1 advantage in 4 months. Germany's most feared weapon had become its most expensive liability. Every 88mm gun consumed resources that could have built 6 mortars or 3 machine guns or 12 anti-tank rifles. The pursuit of perfection was killing German defensive capability through resource starvation. Post-war analysis by American Ordnance Department studied captured German factories and production records. Their conclusion was devastating for German military philosophy. The Flak 88 represents German engineering at its finest and German strategy at its worst. Magnificent weapon, catastrophic production system. The gun was so good it became irreplaceable. So complex it became unbuildable. So expensive it consumed resources needed elsewhere. American military adopted opposite lesson. Adequate weapons built overwhelmingly fast beat perfect weapons built slowly. This philosophy would dominate American military production through Cold War. M60 tank, M16 rifle, M1009 howitzer. None were perfect. All were adequate. All were built in massive numbers, overwhelming any opponent through sheer material superiority. The final historical irony. Post-war Germany adopted American production philosophy. Bundeswehr weapons designed for mass production. Simplified manufacturing. Commercial components. Rapid assembly. The nation that invented precision engineering learned that war is won in factories, not laboratories. Speed of production matters more than perfection of product. The Flak 88 remains legendary. Museum displays worldwide. Historians praise its versatility. Veterans remember its effectiveness. But the gun that won the war was the adequate weapon you could build fast enough to put everywhere simultaneously. That was the American 90mm. Not perfect, just enough. Everywhere. Always.